Okay, activity 31 for Math 192. We're going to talk about some probability and a little bit of counting principle here, but we're going to focus on the spinner here at the beginning here. Alex has a spinner. Seems to be a somewhat unfair spinner. Here, pink covers half of the circle, purple covers 1/4, and silver seems to cover 1/4. So when we talk about probability of spinning pink, it is 2 out of 4. Probability of spinning purple is 1 out of 4, and silver is 1 out of 4 as well for this particular spinner. If we're drawing cards, it's not the same thing. So we're looking at a spinner here out of that, and the explanation of that is that if you cut all of the pieces into the circle into the equal pieces, you have this one is pink, and this one is also pink. Okay, so that's why that's going to happen there. All right, so part A asks us to draw a probability tree for this experiment. So probability tree works like this. So for this experiment, we're spinning it 2 times. So you're going to have a beginning of each first spin. So there's how many colors are there to begin with? There are 3 colors. There's pink, purple, and silver. So you're going to start with your first spin is going to have 3 choices. You're going to have pink, purple, or silver. First spin has that. Probability of pink in this case is 2/4 or 1/2. So we're going to write 1/2. Probability purple 1/4. Probability silver 1/4. Okay, and that's coming from the sectors of the spinner. Okay, and then when you spin the second time, each color is going to have 3 different options there. If we go to pink again, the probability of pink, the second spin, still 1/2. The probability of purple, still 1/4. Probability of silver, 1/4. Same thing's going to happen here on the purple spinner. We're going to shoot off 3, pink, purple, silver, 1/2, 1/4, 1/4. Silver happens, you got pink, purple, silver. Ran out of room there, so it's hard to see. But again, 1/2, 1/4, 1/4 are the probabilities. Okay, so that's the probability tree is like a tree, like a factor tree type thing. But we're splitting off each node or stopping point is where we've spun the spinner here and your options from each of those times. And then you just put the probability with it, okay? Part B is where we start using that, and it can help us to find the probabilities. So using this tree to help us, and I'm also going to talk about doing it in other ways. What's the probability that the colors spun are pink and silver in that order? So that means your first spin has to start at pink. So we're going to go this direction. So the first spin is pink, and then the second spin is silver. So that's a 1/2 probability of getting pink when we spin the spinner, and then a 1/4 probability of getting the silver. So we take 1/2 times 1/4, you get 1 out of 8 probability of that happening. Okay, so probability pink is 1/2, probability silver 1/4, probability pink, silver, and multiply those together. 1/2 times 1/4. You could find that without the tree, but it's nice to look through the tree and be able to get that as well. Okay, so explanation is here. Actual work there. Probabilities colors of the colors spun are identical. Okay, identical. So that's pink, pink, purple, purple, silver, silver. Okay, so probability. Let's do probability of pink, pink. So that'd be 1/2, 1/2. Probability of pink is 1/4. Probability of purple 1/4 probability getting purple the first time. 1/4 probability the second time. 1/16. And then probability silver be 1/4 1/16. Okay, so all of those probabilities added together, 1/4 plus 1/16 plus 1/16. So that'd be 4/16 plus 1/16 plus 1/65, 6/16, which would be 3/8. Probability that the colors spun are not identical. Okay, so we found the probability that they are identical. Probability of not identical is the complement of that. So it's 1 minus 3/8, which would be 8/8 minus 3/8, which is 5/8. That is the easiest way to find the not on that. Is use the complement. You could also figure out probability of pink, purple, pink, silver, pink, and then purple, pink, purple, silver, and then silver, pink, silver, purple, and add all those together, you're going to still end up with 5/8 there. So the quickest way is not the complement there. Part E, it says, what's the probability the first color spun begins with the letter P? Okay, so that would be probability of, you got a first color spun would be pink and purple. So the silver, you got 1/4 times 1/2, 1/4 times 1/4, and so the probability of silver is 1/4 coming first. So the probability of one of the P colors coming first would be 1 minus 1/4, which would be 3/4 probability of that happening. Fairly simple one there if you just think about just the first spins, because that's the only one they did ask about. Okay, all right, let's go to a little bit more difficult counting principle type problem. Okay, so on this one we're going to look at how many ways we can arrange the letters in this long little think about past phrase for like if one of the safest things that you can have on a for a password is that what's called a passphrase, and it's just one big long word, but it's usually like a sentence of some sort. So Thanksgiving is in November. That is a long password, but you normally have to have letters and numbers and some sort of special character, but it's the same idea out of that. So how many ways that can that be arranged? Okay, so the difference in this and what we did in activity 30 is that we're arranging these letters, and we can count up how many letters there are. There are 24 letters in that collection there. So we would think, oh, that's 24 factorial because you have 24 blanks there. But because we have some repeated letters, we have to take those parts out. So what are the repeated letters? So as I go through here, I think about, okay, well, is T repeated? No, T is not repeated, so we don't have to take care of that. H is not repeated. A is not repeated, but N is repeated. So the N is repeated 1, 2, 3, 4 times. Okay, so what we've got to divide by is a 4 factorial because of the N's. Okay, I go to the next letter. Is K repeated? No, so I don't have to worry about it. Is S repeated? Yes, S is repeated 1, 2 times, so that's a 2 factorial. Okay, so this is because of the S. And then we go to the G. G is repeated 1, 2 times. So there's another 2 factorial. That one is because of the G being repeated. Okay. The next letter is an I. I is repeated 1, 2, 3, 4 times. So there's another 4 factorial in there for the I's. And then the V's. 1, 2 V's. So that's 2 factorial for the V's. Okay. And then we go to the next letter. I, we've already taken care of. N, we've already taken care of. G, we've already taken care of. S is, there's S, we've already taken care of. I's, N's, O's. Is O in there more than once? No, it is not. V, we've already taken care of. E's, yes, there's E's. November has 2 E's. So that is a 2 factorial. B's, not repeated. R's, not repeated out of that. So all of these are these factorials in the denominator are representative of the repeated letters or items, and it's the factorial. How many of those are in the set? Okay, so if we were dealing with a set of Matchbox cars, and there were 3 red Camaros in the set, you would have to divide out 3 factorial for the red Camaros if you're arranging all of them. Okay, so we're going to use it says here to not calculate these actual numbers, because your calculator is going to experience some overflow issues. 24 factorial is a very large number. If you go to divide that out, it can do it, but it's going to be so large a number still, even by dividing with all these, that it's going to uh, be too large for your calculator to display for you. Okay, so here are the things that you need to know. Okay, top number is total items. In this case, it's letters. And then the bottom part is the repeated items. And in this case, it's letters. All right, how many ways can the phrase Thanksgiving is in November be arranged if the first letter must be an N? Okay, so that changes the top part of that problem, in that you have to have an N first. So how many N's are there? There are 4 N's to begin with. So you have 4, and then how many letters are left? If you take out one of those N's, there are 23 left. Okay, so the 4 is the number of N's that you have to begin with, and then there's 23 blanks after that. So that's the 23 factorial. Now the bottom part is your repeated pieces there. So your 3 factorial here, what does that represent? That's representing the other 3 N's that are in that arrangement. Okay, so these are the remaining N's. And again, we have the 2 factorial for the G's, the 2 factorial for the S's, and it doesn't really matter what order you're doing these in. 4 factorial for the I's, 2 factorial for the V's, and 2 factorial for the E's. Again, just setting it up and working from there. All right, C part. How many ways can the letters in the phrase Thanksgiving is in November if be arranged if the first letter must be in and the or the last letter must be an N? Okay, so what's it look like for the first letter? We know that's 4 times 23 factorial. That's the first being an N. If it's the last, letter being an N, then or the last letter being an N. So the first letter or the last letter being an N out of that. So you could have 4 times 23 factorial there. Okay, so both of those are the same calculation, no matter what the arrangement is there. And then we have to subtract away, what if it's both of them? Okay, or includes the both. So this is both. So if it's on the front, there's 4 possibilities on the front. And then the last piece, there are 3 possibilities. And then there's 22 factorial left over to deal with. And then we got to divide out the repeated values. Okay. So again, we're going to have the 3 factorial, or excuse me, we'll have 2 factorial for the n's, 2 factorial for the g's and s's. Oops, I already did s. Let's do g here. 4 factorial for the i's, and then 2 factorial and 2 factorial for the v and the e, just like we've done on the others. Okay, why did I change this to 2 factorial? Because we're using the 2 of the ends there, front or back. Okay. And again, it's set up, not calculation. Your calculator is going to deal with some overflow issues if you try to work that out. Okay. So again, possibilities of arrangements on the top, and then you're dividing out the factorials for the number of items or terms that are repeated in that list, whether it's letters or items, cars, books, you know, coronavirus test, something like that. Okay. Hope you guys are doing well. If you got questions, shoot me an email. I'll try to explain it a little bit better.